Hello, Algebra. Today we are going to move on to 4.1, solving systems by graphing. A system of linear equation is just a set of two or more linear equations. The solution of a system will be an ordered pair. It's where the two lines or more lines intersect. That ordered pair must have an x and a y. If we're going to solve by graphing, what we want to do is to graph both lines on the same graph. So before we've graphed y equals negative 1/2 x minus 2, we know that the y-intercept is negative 2 and that the slope is negative 1/2, which means I'm going to go down 1 and right 2. I'm going to start off with the y-intercept at negative 2, down 1, right 2, down 1, right 2. If I can't go down and right, I'm going to go up and left. Up 1, left 2. And there goes my line, my blue line. Let's get another color. We're going to do another one, and we're going to make it an orange line. So for the next function, my next linear function, y is equal to negative 3/2 x plus 2. That means my y-intercept is at positive 2. And my slope is negative 3/2. That means I'm going to go down 3 and right 2. So my y-intercept is 2. I go down 3, right 2. Down 3, right 2. Ooh. I could also go up 3 and left 2. So there goes my orange line, my second linear function. This coordinate where they intersect, that is the solution to the system. This is where both lines cross over. And so the solution to this system is going to be at 4, negative 4. That is the point where both functions have in common. That's the solution. And so we've really already done 4 and 1 per se. But again, we just put them together in our graph. So number 2, I'll do the first one in orange. That means my y-intercept is at negative 3. And my slope is 1/3. That means I go up 1 and right 3. My y-intercept is at negative 3, up 1, right 3. If I can't go up and right, I could go down and left. So there's my line. For the next one, I want to graph it. I could graph it from standard form because my x-intercept right? So I could graph from standard form where my intercepts are, my x-intercept is 1 and my y-intercept is 1. And then I would eventually get there, or I could go to my best friend slope-intercept form, which means I will have to change this around because right now it's not in slope-intercept. So that would have, I'll put it over here, x plus y equals 1. So I would minus x on both sides. So that y is equal to negative x plus 1. That means the y-intercept is at 1 and the slope is negative 1/1. So I'm going to go down 1, right 1. So again, here I would still start at 1. Then I would go down and right, down and right, down and right, down and right, down and right. Hopefully we already see that point where they intersect. If I can't go down and right, I go up and left. And so we'll push. The solution to a system or to this system is right here, that point where they intersect. It comes with an x, which is at 3, and the y, which is at negative 3. That is the solution to the system. So if a point is a solution to the system, that means it must be a part of both lines. And in order to then tell if this point is a solution to the system, all I really have to do is substitute it to find out if it's true. So we have 2, I'm sorry. we have here x plus 2y is equal to 6. This is your x, and this is your y. So x is 4 plus 2 times y, which is 1, should equal 6. Well, 4 plus 2 should equal 6, and indeed 6 is equal to 6. I know this point is on the first line. Let me check the second line. The second line has an equation of x minus y equals 3. So if x is 4, I simply substitute 4 in for x. And if y is 1, I substitute 1 in for y. I am getting that from this coordinate. Is this coordinate a solution to the system? It has to be the solution for both lines. So 4 minus 1 is 3. Yes, it is true, because this point was true for the blue line and this point was true for the red line. Then yes, it is a solution to the system. It was a part of both lines. Let's try number 2. So the first line I'm going to do is 2x plus 5y equals 8. Again, I'm going to get my x and my y from the actual coordinate. This is x and this is y. Every coordinate has an x and y. So this is 2 times negative 1 plus 5 times 2, and it's equal to 8. Negative 2 plus 10 should equal 8. Is that true? It is. So I know that it is a solution for the first line. Let's check the second line. I'll use green. So the second line is 3x minus 2y equals 5. X again is negative 1, and y is 2. So let's see. Negative 3 minus 4 should equal 5. Negative 7 is equal to 5. That's not true. So this coordinate is a part of the red line, but not a part of the green line. Therefore, it is not a solution to the system of equations. It's true for one line, but it's not on the other line as well. Go ahead and test out 3. Pause and test out 3. All right, and so we would see that, yes, indeed, that is a solution to the system. Now let's check it out on a word problem and see exactly what these things mean. Here's Bolorama. Bolorama charges $3 per game plus $2 for shoe rental. There's a bowling alley. Bowling pins, they're charging $2 per game plus $4 for some shoe rental. For how many games will the cost to bowl be at the same be the same at both places, and what is that cost? So step one, let's read the word problem. We just did, thought about it, have an understanding of what's happening. We're going to write 2 equations. So let's see, we have Bolorama, let me call this just Rama. Here's Rama. Bolorama charges $3 per game. That's every game. That is the change in. That is going to be our slope. So it's $3 for every game. Every game, it adds $3. Plus $2 for a shoe rental. Well, how many times do you rent the shoe at the bowling alley? Just once. So that $2 is your starting. You got to rent the shoes. You're going to start here, and then it's $3 for every game. That's Bolorama. Let's see, bowling pins. They charge $2 per game. Oh, every game. So that's $2 for every game per, that's your slope, plus $4 for a shoe rental. One-time fee of $4. For how many games will the cost to bowl be at the same for both places? So let's do Rama. We're going to start at 2. And then we are going to, oh, this is going to be our total cost, right? And then it's going to change on your number of games. Because if you do one game, it's only $5. But if you do two games, then that becomes 8 bucks. If you do three games, nine, it becomes $11. So it depends on the amount of games. That's your X that you play. We're gonna go from two up three, 1, 2, 3, and right one says my slope 1, 2, 3, right one. Okay, here's my blue line. And it pretty much has to start here because I can't do negative gains, right? Let's do pins in red. Here's pins, and we start at 4, and then they're up to right one, up to right one. Oh, there it is. Up to the other one would go up. So, and so boom, here we are. Up 3, right one would be somewhere here, and that's here. Either way, that is where they intersect. That's the 2 points that they have in common. And so we see that that coordinate is 1, 2, 2, 8, 2, 8. Graph the equation, look at the intersection, identify what it means. Okay, so what does this actually mean? That means 2 is your number of game, that's your X, and Y is your total cost, 2, 8. That means that after 2 games, they would play the same amount. And that amount is $8. That's what it means. So we not only have to know where it is, especially in terms of a word problem, but in a word problem, we also have to identify what it actually means, those intersections. All right. So this is solving by graphing. 4.1.